STC-9200 is a 3-in-1 controller typically used in walk-in freezers. There are two versions with different coding, but the same function. With 2 thermistor and 3 output relays, it controls the compressor, defroster, and evaporator fan. Before we start, complete the wiring as you see on the screen. Once power on, it will proceed a self-test. After that shows the room temperature value. If any error codes are displayed, try to check the sensor wire. If the value is readable but not editable, usually because the keys were locked. To unlock it, press and hold the down and up buttons simultaneously for 10 seconds. You will see OFF indicating that the lock is closed. Above is the first section. Next, let's see how to use it. As you can see, it is the room sensor temperature on the display. Let's call it normal state. In order to avoid accidental pressing, single pressing is invalid in normal state. To check the defrost sensor temperature, hold this down button for 3 seconds to get it. By the way, it will be back to normal after 3 seconds. Press and hold the up button for 3 seconds to force cooling. Now the cooling light is flashing. It is the protection delay time of the compressor. If the display does not change, check these conditions. Press and hold the defrost button for 3 seconds to force defrosting. Now you see the defrost indicator is light on. If you want to skip the defrost state to the dripping water state, hold it again for 3 seconds, and the defrost indicator light flashes at this time. Once the dripping time is over, the next stage is the compressor delay time. If it does not change, check these forced cooling conditions. Press and hold the set button for 3 seconds to get the user menu list. It contains only 2 parameters. The first one is set point, it is a position. The second code is the span, or distance from the set point. These 2 parameters together determine the target temperature range. The sum of this part is the upper limit to activate the compressor. This is the lower limit that informs the compressor to stop cooling. Now press the set button to check the existing return difference. The minimum value could be 1 degree. Let's change it from 2.0 to 2.3. Just press the up key 3 times. One more tip, hold down the up button and don't release it, it will move faster. After configuring all the data, you can save it by long press the set button for 3 seconds. It will back to normal state. Of course, you can leave it alone, it will auto-save, and back to normal state in 10 seconds. By now, you have mastered the basic skills. The following section is about advanced settings in the admin menu list. Firstly, press and hold the set and down keys simultaneously for 10 seconds to access the admin menu list. You will see the set point code. Keep pressing the up key, and you will find up to 20 parameters in this list. But don't worry, after a few minutes you'll see how easy it is. The full menu list contains a lot. We'll break it down into 4 blocks to cover. The first part is about temperature settings. We mentioned these 2 parameters in 2.4, we'll not repeat them here. To avoid user missetting, you may want to set a safety margin to limit the set point. This is the upper limit, and another one is the lower limit. Here is an example. Assume the set point is 15 degrees currently, the upper limit is 25 degrees, and the lower limit is -10 degrees. You want to make the new set point to be -18 degrees, the new upper limit will be -5, and the new lower limit will be -25. Firstly, you should change the lower limit from -10 to -25 degrees, then change the set point from 15 to -18 degrees. At last, modify the upper limit from 25 to -5 degrees. What we have to emphasize is that the sequence is important. If you try to change the upper limit from 25 to -5 as the first step, you will find it cannot reach to -5, because the set point is now 15 degrees, and the upper limit must be higher than the set point. Therefore, once you find that the set point is stuck, you must first change the safety margin. The last one is the delay time to protect the compressor, to avoid repeated start and stop in a short time. The second part is about the defrost. This controller manipulates the defrost by time and temperature settings. The first 2 parameters are the defrost cycle interval and running time. Next is the temperature of the defrost sensor near the evaporator. Once reach this value, the defrost will end. This option prevents the water from refreezing. There are 2 kinds of defrosting devices that can be used here. electric heating device, and hot gas from the reverse rotation of the compressor. This option determines when to start timing the defrost cycle. The screen defaults to display the room sensor temperature during defrost, but you can change this value to display the defrost sensor temperature. The third part is about evaporation fan. The table is clear, but not intuitive. Let's turn it into a mind map. Now, you can see that we should check this value first. If you want the fan to start 5 minutes before the compressor starts, just set this parameter to -5, that's all, without the next step. Because once this option goes below 0, the other parameters are useless. In addition to the earlier than option, 3 other options exist. Firstly, let's set the delay time to a non-negative number, for example 5 minutes. If you want the fan to be triggered by the evaporator sensor temperature, confirm the fan output like this, which is actually the factory default. Then, change the starting temperature in this code. Finally, change the stop temperature in this option. That's the end. If you want the fan to work continuously beyond the defrost phase, just select this option, no more steps required. If you want the fan to start after the compressor, adjust this to your expected delay minutes. Finally, make sure this parameter is the same as here. These are the time settings for all 4 fans: before, temperature-based, sync, and delay. The last part is about the over-temperature alarm function. You may wish to be alerted once the room temperature exceeds a safe range. This device allows you to define this range. When you set these 2 parameters, please keep in mind the upper limit should be higher than the compressor startup temperature, yes, above the sum of the set point and hysteresis, and the lower limit should be less than the set point. The third option is the delay time before the alarm. Sometimes you have to set a narrow safety margin, but small span often cause alarms to start and stop frequently within a short period of time. That is why you need a delay time here. When the over-temperature alarm occurs, the device is screaming, the reading is flashing on the display. You can press any key to stop screaming, but the reading will not stop flashing until the room sensor temperature returns to the safe range. By the way, if you find code like this, please note that these are not over-temperature alarm, but are error codes. In most cases, the cause is an open or shorted sensor. Now we have everything set up. If you still have any questions, please visit our website for more information. Thanks.